Hello calculus students and seekers of truth. Welcome to the video lesson on solids of revolutions around a vertical axis. And so we have this problem here. Find the volume of a solid formed by rotating y equals e to the x around the y-axis. And I needed to add this in bounded. This is part of the problem. Okay? I'm not inventing this as a solution. This is part of the problem description that I just forgot to type up. It is bounded by y equals 1 and y equals 3. So y equals 1 happens to be here, and y equals 3 is somewhere up here. Now, this time, instead of rotating around a horizontal axis, we rotate around a vertical axis. So it's going to look something like this. And we are interested in finding, we end up with a circular cone-like object again. And we're interested in finding, that's the circular surface of this thing, and we're interested in finding the volume of this object. Well, it's the same as what we saw in the previous video. We're going to add up the areas of an infinite number of circles. So I'm just going to draw one sample one in here. So essentially we have, that's one circle, and we have an infinite number of these. So, I'll use a pencil. Here's like another circle that's higher than that. But we're just gonna keep on adding all this up, and the sum of all these areas of these circles will in fact give us the volume of this object. Okay? So as we did before, we're gonna start out with the formula for the area of the circle. So we're going to integrate from something to something. We'll figure that out in a minute. This is going to be pi r squared. And we're going to integrate along the y direction here. In other words, we're stacking these circles one on top of each other. So we're going to integrate along dy. And if you notice, this is also a very nice problem. The radius of each of these circles is the x values of the function. So the radius is equal to x. Okay. So that being the case, we are going to convert this in terms of x. So this is going to be the integral from something to something of pi x squared dy. Now, since we're integrating along the y direction, we need to convert x in terms of y. Hence the all caps, remember to change the variables. So it's not too difficult to figure out. Y is equal to e to the x. So the natural log of y is equal to the natural log of e to the x. Therefore, the natural log of y is equal to x natural log of e, which natural log of e, remember, is 1. So x is equal to the natural log of y. So we can update our results here. We're going to integrate. I'm going to pull out the pi here. Instead of x, we're going to say natural log of y quantity squared dy. Okay. And the limits of integration is also going to be quite nice because it's sort of given to us here in the problem. We're going to go from y equals 1 up to y equals 3. So from 1 to 3. Okay. And now all there's left for us to do is to compute this. I'm just going to skip ahead a little bit here because I want to move on to some other concepts. So I'm going to let the calculator do the work. Also, depending on whether you're taking Calc AB or Calc BC or Honors Calc, you may not know how to integrate the natural log of y yet. So you might have to rely on a calculator anyways. But at the moment, we will just use our calculator to speed up the process here. So I got 8.142 as my final answer when I type this into a calculator. Okay, so now we've seen two examples, one of integrating along the x and one along the y. We'll move on to the next example where we mix up multiple functions.